Hello there, welcome to my channel on chemistry lessons. Predominantly it focuses on AQA A-level, but it also covers the BTEC Applied Science specification as well. Most of the videos at the moment do focus on full lesson content, but my aim is as we progress and grow that we'll end up with some shorter, sharp revision videos as well. Please subscribe, let me know what you think. Make sure you don't miss out on any of those future videos. Good luck. So this video is lesson 3 of 3 on the alkanes topic, which is a first year AQA organic topic. So if you've missed the first couple of videos, go back in the playlist and find them. So yeah, final lesson of this topic. Let's not celebrate just yet. So don't be caught out by the very short spec point here, because there appears not to be an awful lot here when it just says the reaction of methane with chlorine. Students should be able to explain this reaction as a free radical substitution mechanism involving initiation, propagation and termination steps. So it feels very, very short. I'm going to look at some terminology first off though. So a free radical, something that's a free radical is a species with an unpaired electron. So you may not have realized, but usually we have pairs of electrons. Electrons are paired up, but species that have having sound issue. Right, moving on. So free radical, it's a species with an unpaired electron. And in this, we will look at halogen free radicals. So halogens with an unpaired electron. In other words, a halogen atom. They have 7 electrons in the outer shell and one of them will be unpaired. So how do we draw a free radical? So if I was to show you a chlorine free radical, I would show chlorine free radical by putting a Cl and a dot. That's showing it's a free radical. And the term substitution just means it's swapping places with something. So it's a free radical substitution. We've got a free radical substituting with something in the alkane. Right, so we're going to look at the chlorination of alkanes. So we take any alkane and I'm going to pick a number between, let's go with, what number? Pick a number between 1 and 10. Yeah, good. We'll go with 7. Well done. So C7H, that's an alkane, 2N plus 2. So 2 times 7 is 14, plus 2 is 16. There we go. So chlorination, they're reacting with chlorine. It's a substitution. What's happening is one of the H's in the alkane will swap places with the halogen. So it becomes CH15 because one of them is gone, swapped with a Cl, and the Cl2 becomes HCl. So that's an overall equation for the halogenation or the chlorination of an alkane. You've got the halogen, you've got the alkane, one of the halogens has swapped places with one of the hydrogens. It's as simple as that. They've swapped, it's a substitution. There is an essential condition here. It must take place with UV light. More on that in a moment. We will see the requirement and the necessity of UV light because it does involve several steps. So that's the overall equation. However, it does take place in several steps and we're going to look at some of those steps now. So the first step is an initiation step, which is what initiates the reaction. And the initiation is always the same. It's the halogen to make 2 halogen free radicals. X is just the halogen. And this is the process that must be in UV light. So if it was a chlorination, it would be a Cl2 molecule becoming 2 chlorine free radicals. That dot is showing the free radical. So there we go. That's the initiation step of the chlorination. If it was using a different halogen, we would just have replaced the Cl with F, I, etc. Now the propagation step, that follows from the initiation. So we have our chlorine free radical. I can put the dot either side, doesn't matter. So I'm putting it on the left now. I think I put it on the right earlier. But I like to mix things up just so you don't get confused if they change the way you recognize them in exams. So propagation of, let's just pick an alkane, I don't know, pick your favorite number pick a number between 5 and 7, excluding 5 and 7. 6, good choice. So we'll go with C6H14. So what happens in the first propagation step is the chlorine free radical will remove one of the H's, become HCl. So the chlorine free radical takes off the H and you end up with C6H13 because it's lost one of the H's, and that is a free radical. And then what happens is that free radical can continue to react, and this time with some more halogen, and this time we get our product. So it takes place over 2 steps, that one. There are multiple different propagation steps that could take place, okay? But ultimately what you're looking for in a propagation step, you start with one free radical and a non-free radical. So the left-hand side is always one free radical and one non-free radical. And the product always contains a free radical as well, and a non-free radical. So it always produces something that can go on and further react. In this case, we had the C6H13 free radical in the top, which could go on and cause further reactions. And in the second reaction, we produced a chlorine free radical, which could go on and react with more C6H14, for example. Now a termination step is the coming together of 2 free radicals to make no free radicals in the products. Now again, there are numerous termination steps. Let me pick this C6H13 radical that we saw in the propagation step, and let me react it with a chlorine free radical. That would make C6H13Cl. That's a termination step here, because we're using up 2 free radicals to make a non-free radical. In other words, this would terminate the reaction. There's no molecules here that would go on and react further. Or we could have 2 chlorine free radicals coming together. That would also be a termination step. That would make Cl2. Or we could have 2 of these free radicals coming together. And that would make C12H26. That would also be a termination step. One issue you're going to have with free radical substitution of alkanes is that you will often get multiple substitutions. And what I mean by that is you won't just get the monochloro or the monohalogen in terms of one halogen being substituted with one hydrogen. It's quite common to have numerous, okay? So what's happening in this reaction is, just to recap, we've got a hydrogen atom being replaced by a halogen atom, and therefore the term substitution. And for every one H atom that's being replaced, one halogen molecule is used and one HX is formed. So let me give you an example of that. So if we were to look at something like propane, now propane is C3H8. Now, if propane was to react with chlorine in UV conditions, under UV light, that's your trigger, remember, to recognize that it's a free radical substitution, we would get the substitution of one halogen to make HCl and your chloropropane. But what can happen is your chloropropane, so your C3H7Cl, could undergo further substitution with another Cl. And what will happen is you'd get a second substitution. That would be H6 now. So we've substituted another hydrogen. So in total, we've substituted 2. We could show this in one step. So we could show it in one step by showing C3H8 plus 2Cl2 produces C3H6Cl2 plus 2HCl. So that's what the second bullet point is saying here. It's saying that for every substitution, if you undergo multiple substitution, and in reality you would end up with a mixture of products, but the exam question will be very specific in terms of what they're expecting you to produce. So here, if I was asked for an equation from propane to dichloropropane, I would require this second equation. That's my overall equation. Okay, again, I could be asked for initiation, propagation or termination equations. And again, they will be specific in the question. So the examples you've seen today are just examples. So in summary then, what I'm trying to say here is, don't be memorizing the equations in this video. Instead, be aware of what makes these stages. So what makes the initiation? What's a propagation? So being able to recognize and identify the different steps rather than learning the specific equations. Because one thing for sure is, in the exam, the questions and the examples used will not be the ones used in this video, and they won't be the ones that you recognize from revision guides or textbooks. So it's recognizing the steps. And hopefully in some of these exam questions that we're about to do, you'll recognize what I'm trying to say. So first question then, if you'll pause the video, have a go at the question, and when you're ready to go through the answer, you can unpause the video. Okay then, so which equation represents a termination step? Now, without even looking at the equations, I'm not going to even look at any of the answers yet. What do I know about a termination step? A termination step, that's one which will terminate the reaction. It's the coming together of two free radicals to produce a non-free radical. Okay. Now, if I look at A, we've got a non-free radical with a free radical, producing a free radical and a non-free radical. So that could be a propagation step, and therefore not a termination step. So the answer is not A. B, likewise, that's showing a propagation step because we've got one free radical with a non-free radical producing a free radical and a non-free radical. And C, again, we've got a free radical with a non-free radical producing a free radical. So again, if I was backed into a corner, I'd call this a propagation step. Going to D then, I've got a free radical with a free radical to a non-free radical. That fits exactly what I said at the start. So without even looking at the answers, I'm making sure that I understand what a termination step is. Right, question 2 then. 6 marks here. So have a go at the question, and when you're ready, unpause and we'll go through the answer. So this is what I said a couple of slides back then about the examples being different. So they want an overall equation for the formation of trichloromethane. So what's trichloromethane first of all? It's a carbon with 3 chlorines, and it must still have a hydrogen then. So methane is 1 carbon. If it's got 3 chlorines on it, it must have 1 hydrogen too. So that's the formula for trichloromethane by the reaction of chloromethane with chlorine. So chloromethane will be CClH3. So we're going from CClH3 to CCl3H. Now what I'm doing here is we're substituting 2 chlorines for 2 hydrogens. That would require the use of 2 chlorine molecules and would produce 2 HCl's. And I would need UV light here, although it hasn't asked me for conditions, so that's not necessary. But that there is my balanced equation, my overall equation. It doesn't show any propagation or initiations. That's just the overall equation. Okay, name the mechanism then. The mechanism here is free radical substitution. So free radical substitution. Now I've got dichloromethane as an intermediate in this reaction. Yep, that kind of makes sense because it would have to go from chloromethane to dichloromethane and then to trichloromethane. Yep, so that makes sense to me. So that's an intermediate. Write an equation for each of the following steps in the mechanism for the reaction of dichloromethane with chlorine. Right, now the initiation step is always the production of your free radicals, and the free radicals in this mechanism are going to be chlorine, and we would make that from Cl2, so we would make 2 chlorine free radicals, and I would probably write UV light above here, but again it hasn't asked me to mention conditions, but I know UV light is necessary. The first propagation step then uses your chlorine free radical with dichloromethane, and it's going to produce a radical, the CHCl2, so it takes off your HCl at this point. There's your first propagation. Your second propagation is that free radical that you've just produced with another chlorine molecule, and your chlorine free radical is regenerated, and we'll end up with CHCl3. And they want a termination step, but they're being quite clear on what they want. They want their chlorination step to be a C2H2Cl4. So how could I make that? What free radicals could come together? And there are a few possibilities here. The most obvious one for me at this point, though, would be a CHCl2. It would be two of these coming together, and that would produce C2H2Cl4. There are other possibilities here as well, okay? As long as you're using up two free radicals that would exist in this mechanism and you're producing the correct product. Okay, question 3 then. You know the drill. Have a go at the question, and when you're ready to go through it, unpause the video. Trifluoromethane this time, so it's not chloro, it's fluoro. Can be used to make the refrigerant chloro-trifluoromethane. So what does that look like? We've got a chlorine with 3 Fs, a carbon with 3 Fs, sorry, and 1 chlorine. The reaction is a free radical substitution reaction similar to the reaction of methane with chlorine. Yes, we get that, okay. And they're reacting it with chlorine, so we're substituting a H with a Cl. It's a free radical substitution. So the initiation is going to be Cl2 makes 2 chlorine free radicals. And again, UV light. Propagation first step, well, it's going to be your chlorine free radical with your CHF3 to produce the CF3 radical and HCl. Remember, that first propagation step is always removing the H from your alkane, if you like, or from your carbon compound. It's removing the H to produce your H halogen or HCl and leaving behind a free radical. The second propagation step is the free radical that you've just made reacting with the halogen again to produce the chlorine free radical and your product, which in this case is CClF3. And it wants a termination to form hexafluoroethane. What's hexafluoro? Hexa is 6, so it's going to be C2F6. How can I make C2F6? It will be a CF3 radical with a CF3 radical producing C2F6. What's the essential condition? Is UV light. Okay, last question then. So it's a fairly lengthy one, this. It's an 11 marker. So you know the drill by now. If you want to pause the video and have a go yourself, and when you're ready, unpause the video. Okay, name this type of mechanism then. We've seen in every question so far, they've asked or they've mentioned the mechanism. And the mechanism is a free radical substitution. Free radical substitution. An essential condition is UV light. Again, we've seen that mentioned a few times. Stages 2 and 3 are the same type, or steps 2 and 3 are the same types. What type? Right, let's have a look at steps 2 and 3. We've got a free radical with a non-free radical producing a free radical and a non-free radical. And we've got the same in step 3. So that's a propagation. So see a propagation step as one that uses up a free radical but also generates one as well, which can continue to react. And you can see a termination reaction as the type of step that stops the reaction. There's no more free radicals. So these steps are generated or kind of kick-started by a free radical. They require a free radical. In this mechanism, another type of step occurs in which free radicals combine. Name this type of step. Termination. Write an equation to illustrate this step. So they've left this one open-ended. In the last couple of questions, they've kind of stipulated what they want you to produce. This time they've left it open-ended. So actually you've got quite a few options here, really. Okay, so any two free radicals, just pick two free radicals from the equations above. That would make sense. I'm just going to pick the first two I come across, this one and this one. So I'm going to go with Br radical plus CH3CH2 radical will produce CH3CH2Br. Moving on to B. Further substitution in this reaction of bromine with ethane produces a mixture of liquid organic compounds. Name a technique which could be used to separate the different compounds in this mixture. Right, well, this is testing your understanding of a practical technique to separate different liquids. You've already seen this in alkanes earlier on. It's fractional distillation. So fractional distillation. Definitely fractional because you've got several different liquids here. If you only had two liquids, you would probably get away with simple distillation, but fractional distillation is important. Part 2. Write an equation for the reaction between bromine and ethane, which produces hexabromoethane. So we're producing C2Br6, and it's from ethane, which is C2H6. Now, we've got 6 substitutions taking place here, all 6 of them. So we will need 6 molecules of bromine, and it will produce 6 HBrs. The common mistake here is that people will just go for 3Br2. Remember, for every hydrogen you substitute with a halogen, you need 1 halogen molecule, and you will produce 1 HBr or 1 HX. The compound 1,2-dibromo-1,1,2,2 tetrafluoroethane, that's a bit of a mouthful, is used in some fire extinguishers. Draw the structure. Right, okay. Let's not get too confused. It's only ethane at the end of the day. It's 2 carbons. So it's only 2 carbons. And it's 1,2-dibromo, so there's a bromine on both of them. And it's a 1,1,2,2 tetrafluoro. So there's 4 fluorines, 2 on each. So the name makes it sound very complicated. In reality, it's not that bad. Halothane is used as an anesthetic and has the following structure. Give the name of this one, right? Okay, well this one is, we've got 2 bromo, 2 chloro, 1,1,1 trifluoroethane. Or you could have numbered it the other way around. I could have 1 bromo, 1 chloro, 2, 2, 2 trifluoroethane. The order of the bromo, chloro, fluoro is essential because you must go in alphabetical order at that point. So B, C, F. So the bromo comes before the chloro comes before the fluoro. So just to say the 2 correct answers again then, 2 bromo, 2 chloro, 1,1,1 trifluoroethane, or 1 bromo, 1 chloro, 2, 2, 2 trifluoroethane. Calculate the MR, or the MR here. If you add them all together using the numbers on your periodic table, you get 197.4. And percentage by mass of fluorine in this, so you find out how much fluorine is present. So you add all of the fluorines, there's 4 of them. You add the MR of the fluorines from the periodic table together, you end up with 57. So it's 57 divided by the total mass times by 100. So this is just testing your math skills here. And the answer comes out at 28.9% by mass. So if you're thinking here, well, we've not been taught a percentage by mass before, this is just checking your kind of comfort level with numbers. How comfortable are you using numbers? So a percentage by mass is exactly as it sounds. What percentage of halothane, what percentage of its mass is fluorine? So the total mass was 197.4, but what amount of that was fluorine? It's 57. So what's that as a percentage? Right, that brings this one to a close then. So that's the full alkanes topic covered in 3 videos. Fair enough, it's 3 fairly long videos, but the idea is at the moment that they are full lessons, and as we get towards the end of the course, preparing for final exams, I'll be summarising these in much shorter videos, so make sure you subscribe and you don't miss out on those. Good luck and enjoy. Bye!